Hello everyone, and welcome to today's webcast, Anti-Forensics in Action, Recovering from USB Oblivion. My name is Trevor, and I will be moderating this webcast. Today's featured speaker is Nick Klein, a SANS instructor. Before I turn things over to him, the Q&A portion will take place at the end of the webcast. Please feel free to submit your questions at any point by using the questions window. Right now, I'd like to turn things over to Nick.
Great, thank you, Trevor. Good morning, everyone. Thank you very much for coming. Well, I should say, if you're in Australia, then good morning. I know we've got some folks logged on from the US, so I think it's afternoon there, so good afternoon. And for those of you in Europe or that side of the world, good evening, or maybe even good night. Thanks very much for coming. I really appreciate it. Quick introduction. Let me jump to my slides here. For those that don't know me, I'm director of a company in Sydney called Klein & Co. It's a very creative name. We're an independent DFIR company, so we do investigations for clients into a very, very wide range of cases, everything from data breaches on networks to employee investigations. We do a lot of internal investigations for companies and also things like litigation, even criminal work. So basically this is what we do all day, is we do computer forensic investigations, and we deal with a very wide range of technical challenges. And one of the things that we see is people who do try to cover their tracks. And it's one of the things that's always interesting from a forensic perspective, because at first when you get a situation like that, it can be quite a challenge and it can be quite confronting in terms of how do you deal with it and what do you do. But one of the things that I hope to convey today is if you follow a good approach, if you have a good understanding of what's going on and you use the right tools and methods, you can actually recover quite well. And as Trevor said, I'm also a SANS certified instructor, and as the slide shows, it's really something I do in my spare time, which I don't have a lot of. But I love teaching, and there's two courses that I teach, 408, which is the Windows in-depth forensic analysis, where we really tear apart Windows and look for a huge range of artifacts that we can use to reconstruct activity, and 508, which is the advanced forensics and IR. So, and what I'm going to teach today is really material that comes out of these courses, particularly 408. Again, going back to that concept of how do you approach a technically challenging situation, and by using a good approach and ultimately a good knowledge of what's going on, how do you really deconstruct it and figure out what's happening. So let's jump into it. USB Oblivion. What is USB Oblivion? I first heard of, this is a product, you can download it from Google Code. It's a piece of software, and I first heard of it on the DFIR mailing list, which is the SANS mailing list, a couple of months ago, and I became kind of curious about the notion of it. I think from the name of it I thought, oh, that sounds kind of interesting, I wonder what it does. And when I looked at it, it's a tool that does cover some tracks about USB activity on a Windows box, and it got me to thinking about how would you approach this as from a forensic perspective. How would you get this tool and apply a method to, again, sort of look at what does it actually do, but how effective is it, what artifacts does it destroy, but what does it also leave behind? And I thought that sounds like a really good presentation topic, so I put this together. So let's have a look at it. USB Oblivion is, as I said, it's a piece of software. You can download it from Google Code here, and let me just say right from the outset, this is really important. I'm not here to criticize this product or to point out deficiencies in it. That's not my purpose at all. The developer here has written a product. It does a reasonable job of what it does. That's not my objective. My objective is to say, if you're a forensicator, if you're an examiner, and you're in any kind of technically challenging situation, and it could be an anti-forensic tool like this, or it could be maybe you're doing expert work in a case and someone throws you a really curly question about a particular technical fact, and you think, wow, how am I going to do that? How am I going to deal with this challenge? It could be that you have an employee using other kinds of systems. It could be you have some malware on a system and you're thinking, wow, this is really sophisticated malware. How do I reconstruct what was going on? Again, what I want to demonstrate is not weaknesses in this particular product, but how do you apply a sound forensic approach to deconstruct it? So let's have a look at USB Oblivion. First, let's look at what it says it does. So it's designed to, as it says, erase all traces of USB connected drives. And you might think, okay, that's interesting. Erase all traces of USB drives. If anyone's ever done USB forensics, you might be thinking to yourself already, that's a pretty that's a pretty difficult thing to do because USB devices, when you plug them into Windows, are reasonably noisy, not only in the registration of the device, but also in the user's use of that device and the actions they perform around it. So already you might be thinking, okay, that's a bit of a challenging thing to do. If you read the next line, you'll see it says, from the registry. Okay, fair enough. So erase all traces from the registry. So again, if you do forensics, you might be thinking, hang on a minute, the registry isn't the only place where USB devices leave a trail. So again, there might be other places immediately that you think to look at. Now, let me just also point out, if you're, think of this from the perspective of the user. So a user in an organization who, for whatever reason, wants to cover their tracks. They don't want people to see what they've done with their USBs. And they look up a tool like this and they see it. And they think, wow, look, this erases all traces of USB connected drives. Fantastic, that's exactly what I need. They're not going to understand all of the other USB artifacts that might exist. In fact, they might read on and say, from the registry, wow, this must be a great tool because it deletes it from, that mysterious place, the registry. So a user might take a program like this and try to use it to cover their tracks, but not necessarily do a good job. And that's something that's quite indicative when we have, we see a lot of cases of people who do try to cover their tracks in different ways. Sometimes it's a sort of unsophisticated user. Sometimes it's a pretty sophisticated hacker who takes some pretty careful steps to cover their tracks. But again, it's a difficult thing to completely cover your tracks. If you keep reading, just in one of the next lines, it even says, it creates a .reg file to undo any changes. So okay, if you've used this and you're trying to cover your tracks and maybe you don't realize what's going on, you might not know that actually while this has done a good job of cleaning out your registry, it's actually created a backup. So again, for a forensic examiner, if you've got a user who doesn't understand it and uses this tool in a way that this backup file is created, you've actually still got all of their registry anyway. So from an anti-forensic perspective, from the user's perspective, perhaps it's not going to do exactly what they do. And again, just want to emphasize, I'm not being critical of the tool. It's written the way it is. What I'm trying to show is if we, as forensic examiners, have this in a case, how would we deal with it? How would we examine it? What tools and methods would we apply? Okay. Now, let's think about there's one more thing I'll point out here, the usage of it, USB Oblivion 32 or 64.exe. So again, it doesn't really hide itself. I mean, it runs as an executable called USB Oblivion. It doesn't mask its name or try to cover its tracks in that way either. But now, let's step back from the technical and think to ourselves, what does this program actually do? And this is where when I used to work in the Federal Police in Australia, and there was a very good forensic examiner, and he used to say, he was very sort of old school, and he always used to say, never forget that at the end of the day, you're investigating a person. No matter how technical the work gets, and we do some very, very technical work, at the end of the day, think about what's the context of this activity. So, you have to ask yourself more contextual questions which will paint a proper picture of what's going on. And I'll talk about some of these in a moment. Let me also just divert for 1 second and talk about what's the challenge of anti-forensics. It's actually reasonably difficult to, I would imagine, write a good anti-forensic product that does especially such a broad thing as delete all traces of USB activity. And again, let me say, this product doesn't claim to delete all traces because that would be very difficult. It sort of limits itself to the registry. But if you're writing an anti-forensic tool, there are certain challenges that you have. Firstly, you're always going to be confined by Windows and the Windows ecosystem environment that you're stuck in. So if you're using Windows programming functionality, there's certain stuff you can't do. You can't really wipe a registry key in the way that you can wipe and overwrite file contents. Registry key data is allocated in blocks, and as those blocks are allocated and deallocated, you get slack space in the registry. You get unallocated space in the registry. There are certain techniques you could try to clear out that slack, that unallocated, but you can't just do it through normal Windows functionality. Also, you've got things like clearing a system log. If you have a program that attempts to clear a log, You can clear that log if you've got the right escalated privileges, but clearing it actually leaves a log entry itself showing that you've cleared it. So you've got this chicken and egg problem of how do you cover the tracks of your actions of covering your tracks, if you know what I mean. And then you've got things like volume shadows and other functionality in Windows which you may not know about it, but they inadvertently leave other snapshots or copies of data around as well. So again, you're stuck within the Windows environment, and it can be hard to completely cover your tracks, which you might think is one instance of, as I've said here, the malware paradox. So anyone who's done IR work or malware analysis will be familiar with the old malware paradox. It basically says malware, it will try to hide, but it has to run. And it's in that execution, it's in that running and that use that malware will expose itself. And the same thing applies to some of these anti-forensic tools that we have. So how does USB Oblivion actually work? Let's have a look at it. So you download the program, it downloads as a zip file, and then you expand the zip file. If you have Windows, Windows may do this automatically for you. And you can see, if you look carefully here, the folder that this is downloaded to is the downloads folder. Okay, seems pretty obvious. Why am I pointing that out? If you're doing your forensic analysis later on, and you see evidence that there's USB artifacts missing, and you ask yourself what's going on, if you find USB oblivion.zip and you find it in a user's downloads folder, that might be a little suspicious. That might make you raise an eyebrow and go, hang on a minute, what's this user been doing? If you then look at things like the file system timestamps, you can see when it was created. Again, if you think about the broader context, you might start asking questions like, hang on, if this was downloaded in the downloads folder, it probably came from the internet, it probably came through a browser, so let's maybe launch into some browser forensics and see what it was doing. So again, we're starting to see context that we can use around the use of this product. If you look in that folder, you'll see there's that executable, USB Oblivion 64.exe. You might notice it's actually it's a standalone executable. You don't need to install it. So again, later on when we look at execution activity, we'll see here's a program that this user downloaded and ran from that location at a certain time. Again, pretty incriminating. It also provides a handy README file, so you can go through it and look at what it says it does. Now to run it, pretty simple really. You double-click the executable, it will run, and you can see the messages it gives you. It gives you a warning to eject all your flash drives before the cleaning process, and then it says press clean to begin cleaning. And again, if you think about this from your average user's perspective, they'll think, okay, great, I'm going to, didn't have to install it, fantastic, I can run it, I've got the privileges, I'm going to hit the clean button, away we go. However, if the users don't look carefully, you might notice a couple of very important checkboxes down here. The first one says, actually do a real clean, otherwise you're just simulating, right? So that could be pretty important. So if your user presses the clean button, they might not realize that what they're seeing before their eyes is actually a simulation of a clean. It's not a real clean. And the second checkbox goes back to that registry file that we talked about. So save a backup.reg file. So again, if a user uses default values, they're not really cleaning anything, and they're sort of creating another snapshot for us of their registry, which is kind of neat. But I don't want to pick on just the users that don't understand how this works. Let's for the rest of this pretend that the user does know what's going on. They do hit the button that says do real clean, and they don't save their registry file. So let's say we've got a reasonably informed user. So they do those things, they hit the clean button, and then the program will tell us what it does. Now this is really cool from a forensic perspective, because here's something that could be used as an anti-forensic tool, but it actually tells the forensic investigator what it does. And again, this might seem like very simple stuff, but if you're doing analysis of a tool like this, or if you have a case where you're confronted with a tool that you're not familiar with or you need to understand, get a copy of it, download it, run it, test it, see what it does. If you're looking at USB Oblivion, it's actually not that difficult to see in these screens, these next couple of screens, exactly what it does. So again, it's making our job relatively straightforward. So the first thing you'll notice up the top here there's that backup file that we talked about. And it's conveniently called USB Oblivion 64Win. It's got some information about maybe its execution. And then it's got .reg. That's the registry file that it's backed up. Notice too what directory it's stored in. It's in the documents directory. Remember what directory the user downloaded the program to and executed it from? It was downloads. So again, if you've got a scenario where a user downloads this and runs it, and they do happen to create this reg file, and then they think to themselves, hang on a minute, I want to delete the program file because I don't want the people knowing that I had that program file there. They can delete the program from their downloads, but that's not going to touch the registry file that got created. So again, by understanding the behavior of the tool, you can look for a telltale sign of its use that the user may well not have noticed to delete. It deletes some files. So one of them I'll point out here is the setupapi.dev.log file. Now anyone who's done USB forensics will be very familiar with that. That is the plug-and-play log for Windows USB devices. So when you get a USB device and you plug it into Windows, when you do it the first time, you'll notice that it takes a few seconds. And what does it do in those few seconds? It sets up its drivers. It initializes the device for future use in Windows. And information about that driver setup is stored in that setupapi.dev.log. So this tool, USB Oblivion, will remove that file. Okay, we'll come back and look at that later on. Another thing that I'd point out here is it clears these journals. Now, I've talked about journals. You might be familiar with these as system logs. So the application security and system logs, it goes through there and it cleans those logs. And we'll look later on at what does that actually mean when it says it cleans those logs. Then it goes through all of the various registry keys and values that it removes. And that's quite good. It does a reasonable job of going through all the different USB artifacts in the registry and deleting those out. It looks for mount points. And notice also it touches on different registry keys. So some of these are software keys, there's some system keys. There's also some user keys. So if you look down the bottom of this slide, you'll see HKey users. So it's actually going through user registries and user profiles and wiping or deleting keys from those too. So that's pretty cool. And then when it's finished, you'll see down the bottom it says done. All right, so we've used the tool, we've run USB Oblivion. How do we now examine what it does? How do we figure out what did it do, what artifacts did it delete, but also what did it leave behind? So basically, where are we going to look on this computer to analyze what this has done? And this is where I'll go back to what I said before. A lot of good forensic work is not necessarily about finding the one little artifact, the technically obscure thing that you think will be the smoking gun. It's really about looking in lots of different places, knowing where to look for the evidence that you want, and then reconstructing a story that describes what exactly happened. When I say a story, again, think of the high-level stuff that's going on. So the questions you might want to ask are some of the ones here. How did the user actually get the program in the first place? Where did this program come from? How did it get to their computer? Did they put it in on a USB key itself? Was it downloaded from an email message that a friend sent them, an instant message online? More than likely, a lot of these things in our experience come from the internet. And that leads to the question as well, how did the user find it? How did they know? Did they go to the Google Code website to USB Oblivion and download it? Probably not. They probably did some searching and tried to find it. So if we can get the activity of their searching, then we can get some context around what were they thinking, what were they doing. Some other questions. Where did the user save and execute it from? We've already seen the downloads folder. Does USB Oblivion create its own artifacts? So already in the last few slides, we've seen what it does. We know that it creates that .reg file, depending on how it's used. It may create other artifacts as well, so we can think about that. How did the user find the files that they wanted to take? So imagine this being used in the context of a user who takes sensitive information or has sensitive information on a USB and they want to cover their tracks. So one of the other questions you could ask is, well, how can I find out what the user was looking at? What were they taking? What did they copy to the USB? And theft of IP, theft of sensitive information from an organization is by far the most common case that our team investigates. We see these cases all the time. And USB keys are a very, very common method of exfilling that data, which is again why a tool like this is quite interesting to know about. Did they check the files before they stole them, or maybe after they stole them? Did they, after they copied them to the USB key, did they maybe open them up? If they did, that actually creates a lot of really good artifacts that we can use. How did the user transfer the files to the USB? Did they access the key itself? So is there any activity showing that they accessed the key, maybe open files or directories on it? What other evidence may show key activity? So these are the kinds of contextual questions that you may want to answer. Now, the million-dollar question to all this is, where are the answers? So we've got the questions, we know what we're looking for. And these are not dissimilar to the kinds of questions a company, a client, or a manager might ask you if you're doing an investigation. You know, a manager's not going to say to you, or a client's not going to say to you things like, here's the forensic image. We want you to look at the USB store key in this system registry and tell us the serial number of all the USB devices. No, no, no. They're going to come to you with high-level questions. Show me what the user did. Show me what they took. Tell me what the USB keys were. Tell me when this happened. So our challenge is, where do we go to for the answers for these? Now, if you've done forensics or if you've been thinking about these questions, you might already have in your head a few places to look. Let me take you forward a slide. This is, anyone who's done the SANS 408 course will be intimately familiar with this picture. This is basically the SANS 408 Windows in-depth course in one slide, right? This goes through all of the artifacts, all the groups of artifacts that we teach across a 5-day training course. And this is an incredibly useful diagram. And in fact, if you're not familiar with it, this exists as a poster. Down the bottom there, you'll see, the URL was really long, so I thought I'd just give you a Google string. So if you Google SANS DFIR poster 2012, it'll take you to the SANS DFIR website, and you'll see there's a PDF poster download available, and it actually has this diagram, but in each box, rather than just having a label, it actually describes to you what the artifact is, just in brief terms. What is the artifact? How could it be useful? Where is it? And I think it also has some tools that you could use to get it. So this is a mud map that you can use to run an to create an analysis plan and run an investigation. And this is something that I've used countless times. We use it in our team. When we have a case and we're looking at some of those questions like we had on the previous slide, we will get this diagram out and say, all right, we want evidence of program execution. We want to see if this user used a program that covered their USB tracks. Where would we look? And if you look at that third row in this diagram, program execution, you'll see immediately you've got, what, 1, 2, 3, 4, 5, 6, 7, about 7 or 8. I can't quite see because I've got another window on top. But you've already got a great list of artifacts to start with. So this gives you a fantastic starting point. So if you go through that diagram, you find the places that you're going to look, the kinds of artifacts that could exist, and then you can come and populate this, and that's your analysis plan. So already you've got places to look that, you know, it's a good short, it's not going to give you all the answers, but what a fantastic starting point in terms of places to look to analyze what this person was doing and how this tool was used. So let's look at some of these now. You're probably thinking, all right, enough about approach. Let's talk about the actual tools. Now, again, I'm really, really big on a good, thorough forensic approach. I think I've been in situations so often where you get a technically challenging situation. You think, wow, how am I going to deal with this? But again, just go back to first principles. Think to yourself, what's going on? Where might the artifacts be? And step through them one by one, and you'll often find the answer. So let's look at this. Where's one of the first places you would look when you do USB analysis? The registry, right? The registry is it's described as a very dense location of artifacts. There's a lot of information about what goes on a Windows computer. And anyone who's done USB forensics would know that one of the first keys you look at is your USB store key. In the system hive, so if you look at the top left, there's the system hive, current control set 1, enum key, and under there should be a key called USB store, because that's where Windows, it's one of the places where Windows register the USB devices. So it's not there. Interesting. Is it suspicious that the USB store key is not there? I'd say so. I can't think of many Windows, but I can't think of any Windows boxes that I've looked at that are user boxes, certainly, where there is no USB store key. So the absence of that is pretty suspicious. And if you're doing a case where you're looking at someone potentially expilling data from a company, USB devices would absolutely be on your hit list of places to look. You'd be near the top. So when you start this analysis and you go to the USB store key and you see it's not there, that should immediately raise alarm bells. So this is a very credible first hit. And remember, at this point, we don't know that this USB Oblivion tool is being used. We just see that this key's not there. So how do we try to recover this key? Remember I said before, registries have slack space. Registries have deleted. It's a compound data structure, almost like an SQLite database or index.dat records or any other kind of database. When records are deleted, they're not necessarily wiped. They still exist in a deleted space. Can we look at those? Absolutely we can. Can we do it in this tool? No, we can't. One of the things that we show when we teach courses, particularly 408, is there is no silver bullet tool to forensics. And you'll notice that as I go through this presentation, I'm not using a mainline tool. I'm not saying, just index the contents of the computer and run some keyword searches. Unfortunately, there are still a lot of forensic examiners who use that as an approach. Every case they get, they'll just index it in their big proprietary tool and then run keyword searches. That may not work in this case. So if you use this product, Access Data Registry Viewer, you're not going to be able to get into those deleted areas, but it's just not a capability of this tool. Again, one of the features of USB forensics is and registry forensics rather, there is no one perfect registry forensic tool. We end up using multiple tools for different reasons. So what are we going to use instead? There's a fantastic registry utility called Yaro, produced by TZWorks. Now Yaro actually stands for yet another registry utility. And TZWorks, if you're not familiar with them, is a company in the US who make a lot of very discrete forensic tools. I always think of them as almost like a Swiss Army knife for forensic tools. They've got all these little products that do specific things. They've got a linked file parser, a jump list parser, a prefetch parser, index.dat parsers. In this case, we're looking at a registry utility that they provide. And it's not the only registry utility out there. It does some things better than others. Others do some things better than this. But one of the great things that Yaro does that is hard to beat in other products is it shows you the unallocated space and the slack space in registry keys. So this is a snap from their website. You can see the link down the bottom there. And you can see that top group of keys are normal Hive data, which are viewable by most registry viewers. So that's what we saw in Access Data Registry View. But underneath, we're starting to see different chunks of registry which are actually deleted. And that's what we're going to focus on now. So let's use Yaro on our that's just sort of showing you the way it does path reconstruction. So you'll see on the top left there's a box around deleted keys. This is where it takes it finds all the keys that it can see in unallocated registry space that are deleted and splits them up into those that it can reconstruct a path for and those that it could not reconstruct a path for, but it can still decipher that it's a registry key. So let's have a look now at how this looks in our case. So here's our normal registry. Through Registry Viewer, we're going to look in that same spot for the USB store key, and it's not there. And again, we raise an eyebrow and go, okay, that's a bit strange. We certainly expect it to be there. But now, with Yaro, let's look at the deleted keys and see what we find. And you can see that as we burrow down into that same system hive, Control Set 1 enum, there's our USB store key. And we can see pretty clearly through the big red X, it's a deleted key. But you'll notice that the values of the key are still there. The timestamps of the key are actually still there. They're embedded in the key and they're still accurate. So if you look at the top right there, you'll see the last written time on the timestamp is actually still present and it's a valid timestamp. And when you correlate that with other evidence in this case, you'll see that it still records a timestamp for the USB device connection. You'll notice also on the left, the number, that hexadecimal number that's highlighted, 07084167, etc. For those of you who do USB forensics will recognize that's the serial number of the USB device. So immediately we can show that even though this USB Oblivion tool has gone through and cleared these registry keys, they're still quite available if you have a tool that can use it, and also given the right time. Now, this begs the question, how long do deleted keys last? this can vary. It's a bit like files in the file system. Sometimes they can last for a long time if the computer is not used a lot and the data hasn't been overwritten. Sometimes they can be overwritten quite quickly. So I've had cases where it does get overwritten very quickly and you don't see anything here, and I've had others where the data is here. Now, interestingly, when we did this testing, and the screenshots that you're seeing here come from the testing that we did in our office, when we did this testing, we used 2 USB keys, and we used them in slightly different ways to compare how this tool worked. Only one of the keys appears in this USB store deleted area. So the natural question was, well, where's the other one? And is there a way in which we can dig a little bit deeper and try to find deleted keys that Yaro perhaps doesn't recognize here, but where the keys are still in the unallocated space? Can we search the registry unallocated? You can, and again, you can do this from within Yaro. So in the options menu up the top, if you go to unallocated space, and you'll see these different options, if you hit find strings, it will go through the unallocated space of the registry and pull out, as it says there, strings greater than 4 characters in int32 format. So then it'll produce this list, which you see, of key value data that is found in an unallocated space. And then you can right-click on it, export it to a file, and you've got the value, the full contents of the strings from unallocated in the registry in a text file. And then you can search across it. You can grep across it, do whatever you want. So here's a simple example of where we grep across it, and we've used this string, disk ampersand ven, which you may recognize as the disk and vendor notation that Windows registry uses for USB keys. We've searched across our text file, and you can see a whole range of entries that we found. So these are ones where Yaro might not necessarily be able to reconstruct the path, but it'll still show you this information. And again, that's good enough to show, well, this is a USB registry key that used to exist on this computer in this registry as unallocated. Pretty good evidence that these USB devices were connected. And in fact, those 2 boxes that I've got highlighted, you can see there's our Lexar USB device and our Toshiba USB device, and they're the 2 that we used in our testing with, again, make, model, serial number. So despite the fact that this anti-forensic tool has been used, we can still go into the unallocated registry and pull out those details. So that's pretty cool. But again, let's think about some of the other stuff that occurs when a user uses this USB. So say you've got the scenario of the user it's their last day of work maybe, or they decided to go, and they open up Windows Explorer, they browse through sensitive directories, and they start copying files to the USB. What other activity might exist that we can use to tell this story of what happened? Well, one interesting place to look is prefetch. So you might have seen in the registry we've got this deleted key, we've got evidence that USB store was deleted. That might be enough to go, okay, this user's run something, they've done something to cover their tracks. Let's look at what programs they executed. One of my favorite places to look for evidence of program executed is, of course, Windows prefetch. For those that aren't familiar with it, when you run a program in Windows, it will monitor the activity of that program for around about 10 seconds or so. And in particular, it will look at the files, the DLLs, the other files on disk that that program touches. And all of that information about the execution of this program will be stored in these prefetch files, and they exist in this Windows prefetch folder. So if you look in the Windows prefetch folder on your computer, you'll see these files exist for programs that you've run. Now, if you go into that folder, some of you might be clicking in it now, and you don't see those prefetch files, it's probably because you're running an SSD. It turns out that one of the things that prefetch is most often used for is disk defragmentation. So Windows will use the information about files that are touched by programs to rearrange those files so that they're quickly and easily loadable. It uses them for other purposes as well. But because you've got an SSD, you don't really need to defrag, so the prefetch isn't being collected. So if you get your prefetch files, if you analyze these, you can actually see evidence of when programs were analyzed. And if you find the program you're looking for, you can open up the prefetch file and look at its execution. So here you've seen I found the prefetch file for USB Oblivion, which again is not particularly hidden because the file is called USB Oblivion 64.exe, and there's a small hash string after that. And if I run it through here I'm using a tool called prefetch parser, PF. Again, another TZWorks tool, as you can see their tag up the top. And prefetch parser will pull out certain information about the program, and in particular, here are the two things that I'm interested in most. USB Oblivion 64 has an execution count of 2, was last executed at that time. Now let's start thinking about these timestamps. So we're looking at 9th of February here, so February 9th, it's US notation, 2015, just after midnight, so 13 minutes after midnight. This is a UTC timestamp. So we live in Sydney, we did this testing in Sydney, so we're currently 11 hours ahead, so this is about 11:13, sort of around the middle of the day. Okay. So we can see that the program was run, we can see where it was run from, we can see how many times it was executed and when it was last run. If that time correlates to when the USB registry keys were taken, then that's starting to get interesting in terms of evidence. Let's look somewhere else. Shell bags. What do we use shell bags for? So again, I painted the scenario that you've got a user, they want to steal information from the company, they want to browse through directories on the network. How do we show what they were doing? Is that information stored anywhere about you browsing directories through, say, Windows Explorer? Turns out that it is. So when you go into directories in Explorer, you might have noticed that if you select to show the files in a different way, say you don't want to see them alphabetically, you want to see them in order of last modified time, or maybe you want to group them by file type, or maybe you want to show them as icons instead of just files with details. If you select any of those and you then go out of that directory and then you come back into it, have you ever noticed how Windows knows how you like to look at those files? Because it will show them to you in the viewing mode that you previously had. Every time that happens, every time Windows tries to do something that's user-friendly, that means from a forensicator's perspective, you should be thinking, hang on a minute, how does Windows know that? Where did it store that information? And sure enough, the place where it stores that is in the registry, in these registry keys called shell bags. If you're not familiar with shell bags, they can be a bit confusing at first, but they're very, very cool because they do trace for us a path of what directories a user was accessing through Explorer. I'm going to parse these. The way I do it is I'm using a tool. I don't have enough time to go through every single option of what I'm doing, but I'll just provide some highlights for you. So I'm going to use a tool called SBAG, which again is another TZWorks tool. I'm selecting the CSV output. I'm running it against a registry hive called userclass.bat. This is a hive where most shellbag information is stored for user's activity, and I'm just redirecting the output to a CSV file. Now, the beauty of CSV, of course, is that we can run it in one of my favorite forensic tools, Microsoft Excel. So we've got our CSV, we open it up in Excel, and you can see this is starting to show us information about a user's browsing activity. And I've highlighted a few folders there in yellow, and you can see around about this time, or just preceding it, 23:59:23, so again, just before midnight UTC on that day, we've got the user browsing through certain directories on the Office network. Right? Interesting. One of the common defenses you get when we do theft of IP cases, and we show this, is users will say, but I had access to those folders anyway. This is my job. You know, everyone's got access to those. I access them all the time. Why is this suspicious? A lot of good forensics is not based on the artifacts, it's about the context. So being able to pull out timestamps for this user's activity can be really valuable, because you can say, well, yeah, we know that you had access to those folders and you would access them, but the sequence in which you access them, one after the other, on your last day of work, is not necessarily, it doesn't suggest that you were just being a conscientious user, and in the context of you using these USB keys and then the USB Oblivion tool, this is to me painting a picture of you or someone who's systematically looking for the kinds of data you want. And it's always difficult to describe someone's intent through computer artifacts, but again, if you build a good picture, you can start to see what's going on. Interestingly, if you go down this shellbag listing, you can see, again highlighted in yellow, here's another entry where the user actually accessed the USB Oblivion downloads folder, and this is 10 minutes past the hour on the 9th of February. So they've actually, and this is where it's hard, because again, if you're covering your tracks, how do you cover the tracks of you covering your tracks? So you've downloaded this tool. Even if you delete this USB Oblivion folder later on and think, haha, I've deleted the tool that I used, there's still various artifacts that show that this existed and that you opened it and that you accessed it and that you executed it. So covering all of those tracks can be really quite difficult. Where else can we look? Link files. Link files are one of my favorite artifacts on a Windows box because they just store so much information about what a user has done. Here's a link file that we've extracted. So one of the things that we did when we did the testing is we copied some documents to the USB and then we opened those documents. And again, if you're familiar with forensics, you'll know that if you double-click a document, say a Word document in Windows Explorer, Windows will create at least, I'd say, 4, maybe up to 8 or so artifacts, independent, separate artifacts showing that you opened that document. Deleting 1 or 2 artifacts you can do to cover your tracks. Deleting all of them, deleting 6 or 7 or 8 artifacts, even knowing they exist, most forensic people won't be able to rattle off all of the 8 or so places that Windows records evidence of a user opening a computer. So your average user who's trying to cover their tracks, that can be really difficult. So let's look at a few interesting ones. Here's a document called computer examination form.docx, and this was opened from the USB key after the user copied it to the key. The act of opening it created a link file, and if we look inside the link file, you'll see it clearly shows us the document that was opened, when the file was last modified, so we can use that to maybe check against files on our file system to see if they match. And also, notice this target created box, the lower one that I've got highlighted in red. What does that tell us? Link file, when you open a document and a link file gets created, that link file embeds inside it the timestamps, the file system timestamps of the target document. So in this case, the target Microsoft Word document. What does that mean? That means that this copy of the computer examination form was created in its current location at 23:58 hours on the 8th of February. So again, around that midnight timestamp. But what is that location? If you go a little further down, you can see in the bottom red box, it's a removable drive. There's the serial number. There's the label, which we saw in our registry, the Lexar USB key. Mounted at E drive, there's the file name. So this link file is showing us not only that the person opened the document from the USB, but by interpreting the timestamps, particularly that created timestamp, we can tell when that document was actually put onto the USB. All of this without having the document, without having the USB key, and after the person's run the USB Oblivion tool to cover their tracks. So you can see there's still, if you know how to piece together the artifacts, there's still a lot of good story that we can tell. And each of the timestamps in this link file actually means something different. So again, when we teach this in the course, we go through every single timestamp and we think about, what does that timestamp mean? What else can that add to the story that we're compiling? I've run the tool against one link file. You can also run it against all the link files. You can just get every link file in one command and parse all of the metadata using the link parsing tool. And you can drop it into, again, your favorite forensic tool, Excel, and you can do examination this way. One of the cool things you can do is you can look at all the link files on the computer and you can sort by that F column, and immediately you can see volume type removable and fixed. You can immediately see what was on a removable drive. And the next column, that G column, actually shows you all the volume serial numbers as well. So this is another great way of looking at how a person has used USB devices on their computer through analyzing their link files. Let's look at a few other things. I'm conscious of the time. I want to leave a bit of time for some questions at the end. So let's move through some others. Let's go back to this log that USB kept, or this information that shows when it ran. One of the things that it did was it removed these files called setup API, and particularly setup.api.dev.log. And you remember before I said, what is the setup API log file? It's where Windows records technical information about setting up plug-and-play devices. So in this case, when you put the USB device in and Windows loads its drivers for the first time, only the first time, that activity, those drivers, and particularly the timestamp and the registration details of the key will be recorded. So you might think, okay, well, can we recover files that are deleted on disk? Yeah, absolutely. It's one of the things that forensics is very well known for. So let's have a look. So the most simple way of recovering deleted files is to see if there's still MFT records, and if those MFT records will show you maybe where the file used to be so that you can recover it as a clean deleted file. So let's do that. We've opened up our very simple forensic tool, Access Data FTK Imager. Most people don't think of FTK Imager as an analysis tool, but it actually has some very cool analysis capability. And we browse to the directory where this file should be, so the Windows Inf folder, and we look for the file. Now this caught us by surprise when we did our testing, because when we looked in this directory, the files are still there. setup.api.dev.log and setup.api.app.log, which we thought would be deleted because USB Oblivion said it would clean them, they were actually still there. Now, I don't know whether this is something strange in the way that we tested. I don't know if it's a bug in the tool. I don't know if it's something else. But clearly, something went wrong in the execution of the tool, and this setup API log is still there. If we look inside it and we do a search for the USB keys, you can see all of that information about the USB installation is still there. And if you look at the timestamp, you can see that timestamp. Now, this is now local time, so you can see it's still happening on that 9th of February, but it's 10:55, and this log file is showing us local. So at that local time, that's when the USB device was inserted, and Windows configured its plug-and-play log, hence the entries here. So pretty cool. And again, you can see how we're bouncing through different artifacts, and we're doing very specific searches. We're not using the shotgun approach of load it into a forensic tool, index everything up, and run some searches. We're being very surgical about where we're looking for artifacts and what tools we're using, and we're slowly piecing together this great story of what this user was doing around about midnight UTC on the 9th of February. So let's look at something else that it did. USB Oblivion reported that it cleaned these journals, the application system and security. Okay, let's see if we can find some evidence of that. Again, one of the chicken and egg problems you've got if you want to delete a log is you can delete a log file. If you get the right privileges on a Windows box, you can clear a log through standard Windows functionality. Problem that creates for you, though, is it creates an additional log entry, and that log entry will tell you that the system or the log file was cleared. So have you wiped that log completely? Well, you can actually still use other forensic tools to try to recover it from disk. But even if you can't recover it, you've still left a trace that you've cleared it. And depending on how it's done, you might also see evidence of the privilege escalation, so you can see the user that did the clearing. So again, it's deleted some evidence, but it's also left tracks that the evidence was cleared. So this artifact that we're looking at on the screen, I would think of as a great piece of evidence that this tool has been run. It corroborates the fact that USB Oblivion was run and it cleared its logs. So it shows, a level of intent you'd perhaps say on the part of the user. A couple of other quick ones. Jump lists. So you'll notice we talked about log files before and how log files record information about documents that are open in different programs. Another great place on Windows Vista and above that stores information about documents open is the jump list. So here's an example of a jump list from my computer. You see I've got various documents related to work that I was doing for Microsoft Word. So this is just the jump list for the Microsoft Word program. These information is always being captured in the background. Even if you don't pin this program to your taskbar, Windows will keep recording information to populate the jump list. And the information that it records will vary depending on what the program is. So in Word, you see this list of recently accessed documents. In a different program like Chrome, you can see it shows you slightly different stuff. So here you can see I've been looking at some thread information. We've been looking at carbon black. We've recently closed this Yaro program or page, yet another registry utility, and there's some tasks there as well. All of that information is stored in these jump list files. If you look at them on disk, they exist in these directories called automatic destinations and custom destinations, and they're buried deep in the user's profile. And each file there in that directory listing, each file is the jump list for a program. So one of those files is the jump list for Microsoft Word. One of those files is the jump list for Chrome. Can we open them and look at the documents inside them, the elements of the jump list? Yeah, absolutely we can. Now what I've done here is I've got the jump list for Chrome and I've opened it up. And inside it, you can see some interesting things. Remember how I said Chrome as a browser will store information about recently closed pages or most visited pages in its jump list? Here's the information that it stores. And you'll notice that it's got information that shows that this user accessed Google, did a Google search. And on the right, it's actually got the search string that they looked for. How to remove evidence of USB usage. Pretty cool, huh? Think about what's going on. This is internet history, internet browsing activity in a Windows jump list file. Why am I bothering to show you this? Because this has interesting uses. Imagine if our user was reasonably savvy. They went out to Chrome, they typed this search, they found USB Oblivion and ran it. They thought to themselves, aha, I've not selected the reg file, so I haven't left that trail. I've made sure to check the box to do a real clean, not a simulation. I've deleted the downloads folder. I've even cleared my internet history, so they can't come back and look at my downloading of USB Oblivion. This still exists. There will still be this jump list that shows their internet activity in a jump list for a period of time. Right? So again, if you don't limit yourself to one place to look for, if you think about different places to look for these artifacts, you've got a much better chance of success. And again, if you've got a user who does try to cover their tracks, and people say, how do you find that? One of the common places to look is you look for anomalies between artifacts. So if you look for evidence of a person opening a document and you think to yourself, oh, well, there's no link file, there's no this, there's no that, but there's a jump list file. If you see anomalies in the artifacts, if you see 2 artifacts where there should be 6, that can sometimes be a good indicator that someone has tried to cover their tracks. So that's pretty cool. So that's, we've stepped through a lot of different places. Let's wrap this all up and look at what have we done so far, what have we recovered. So we've got this user, they've run USB Oblivion, but we've been able to recover some stuff. What's it told us? Well, firstly from the registry, we not only were able to show that there was multiple USB devices connected, we could show evidence that the USB key, that USB store key in particular, has been deleted. So not only do we have still the information about the USBs, but we've got evidence of someone covering their tracks. Then when we looked at all the other contextual artifacts, what did it tell us? Here's our little timeline. We can see the user, and I've just summarized some of the artifacts on the right. And again, this is a very short, this is a quick and dirty analysis. This is not a detailed analysis, which is why I've set up the top findings so far. So in our timeline, we can see confidential docs copied to eDrive, which we got through link file information. We saw network folders being browsed using Explorer, which we got through shell bags. We saw the USB Oblivion file being opened, which came from link files. Also, we saw the browser activity around USB Oblivion, which I haven't listed here. We saw USB Oblivion, the folder itself, being browsed through the shell bags. We saw the program being executed through prefetch. We saw the event logs being cleared upon program execution. We saw the USB registry key. We saw writing activity to that as well. Okay, so we've put together a pretty good story of what happened. All right. Now, guys, as I said, I wanted to leave a little bit of time for questions. I think, Trevor, I might, I'm not sure how you want to coordinate it. Should I hand back to you and maybe people can write up their questions now?
Yeah, no problem. We do actually have a couple questions already, and if while we're answering questions here, if you could just enter your questions into the questions window, we'll definitely get to them here. First question: one of the challenges in our environment is that we're running Windows in a virtualized environment. How useful is this product, both from an anti-forensics as well as performing forensics in a virtualized environment, such as Citrix?
Sorry, can I just clarify that? When you say how useful is this product, do you mean, is that the USB Oblivion tool that was used, or is that the tools that I was using to do the analysis? Maybe whoever asked that question, if they could just add a bit to that. Or maybe
Paul says yes, USB Oblivion.
Okay, so we ran USB Oblivion in a virtual environment as part of our testing, and we got the results that you saw here. I haven't tested it inside and outside to compare how it works. Based on what it does and what it says it does, I wouldn't expect that within Windows in the VM it would act differently. But of course in VMs you've got other considerations like volumes. Often they turn off things like volume snapshots. You might not get prefetch, particularly if you're running on SSDs. And also you might have the VM snapshots as well. So it will operate slightly differently. You might get different artifacts, but I would expect the tool would operate largely, it would try to operate largely the same. So a lot of those artifacts that you saw there, you should be able to reconstruct. One of the other things, though, to consider about virtualization is some people virtualize in order to present a clean environment to people all the time. So if you've got a situation where a user is doing something and then when they shut down their VM it goes back to a clean state, that obviously creates a challenge for you because you're rolling back changes that exist on disk in memory in other places. So yeah, good question though. Any others, Trevor?
Yes. Next question. How can you tell whether a given timestamp shows local time?
Excellent question. Usually you just know. By far the majority of timestamps in Windows are UTC. Most timestamps that you'll see will be UTC. The places you typically see local times will be in log files. So the setup API log that I showed you is local. Also, operating system log files will often present local times as well. So you need to think of time zone offsets. If you don't know, you look it up. That SANS poster might show UTC or local for some timestamp artifacts, or you can just Google it. You can also test your own system. You can have a look at it. You need to be really careful with that. Anyone who's done forensics for a while will know that timestamps drive you crazy. They can be incredibly confusing and really difficult. And you've got not only UTC versus local, you've got the time zone offset, you've got clock skew, you've got things like delay. So, for example, those prefetch files that we showed, they get written when the program gets executed, but not straight away. There's usually, as I said, around about a 10-second delay to when they get executed. So if you don't know that, if you haven't been taught that or understand it, then you might look at a prefetch file and say, hang on a minute, USB Oblivion was run 10 seconds after the registry was cleaned. How is that possible? You know, could he have used another tool? If you don't know that there's a 10-second delay on that one timestamp, you know, you can get yourself into all sorts of confusion. So the short answer is mostly UTC, but log files are often local. But the proper answer is always double check, especially if it's a timestamp that's critical to your case. Definitely double check it, test it out, run the tool, see how it performs on your own box. So yeah, great question.
All right, great answer, Nick. We do have another question. What if the perp deleted entries under USB store instead of all of USB store? Can you detect that?
Possibly. So if you looked at the screens that showed USB Oblivion activity, you'll notice that some registry, sometimes it deletes the registry key, sometimes it deletes the value, which is kind of what you're getting to there. So if the user deleted entries under USB store, if they could, you know, write a tool or use a Windows function to do that, you would see the same thing. But when you looked at your USB store key in the registry, you would see a set of registry keys. Now, this comes down to the attention of the examiner. A lot of forensic examiners will just look at the USB store key and go, well, there's the USB keys that are listed, that's it, right? Most will not, unless they have a reason to, they will not go into unallocated registry space and think, hang on a minute, what if they deleted sub-keys in USB store? Let's look for them. You could still try to look for them in your unallocated registry space using Yaro, as I showed you. The other thing you could do is think about where else do registries exist. So again, on a Windows box, you might be familiar with the regback directory, which is under Windows System 32 config. There's a regback folder. That takes a snapshot of your registry via a scheduled task every 10 days. So again, if you've got a user who does all of this activity on their last day of work and then gives their computer back, you've probably got a snapshot of their registry from 10 days ago. Is that going to help you reconstruct what they did on their last day? No. But if you want to get activity they did further back, then it might. You can also think about things like volume shadow copies, which will have other copies of registries. System restore points for Windows XP systems will store copies of registries. So there are other places you can look as well. So yeah, good question.
Great. Thank you. It looks like that was our final question. So with that,
Cool.
I would like to say thank you so much to our featured speaker, Nick, for his great presentation and for bringing this content to the SANS community. To our audience, we greatly appreciate you listening in today. For a schedule of all upcoming and archived webcasts, visit sans.org/webcasts. Until next time, take care, and we hope to have you back again for the next SANS webcast.
Great. Thanks, everyone. Have a great day.